Hello folks, this is a part 3 video of this exercise 5.3 implicit functions. We were saying some functions are relatively easy, some are like time consuming. So we are doing this 8th problem, which says that it is sin squared x plus cos squared y equal to 1. You have to get the dy by dx. So in the previous problem we had a trigonometric function. There also same problem arose. The given function was slightly complicated, so we assumed it as u. We tried to make it simple and then we got back to the given. Here also we will be doing that because sin squared x, as we are beginners, it's a little difficult for us. As we keep doing, it will be easy. Sin squared x is not such a difficult function to find the derivative, but takes time to get used to. So let's start right away and let's call this function as u and this function as v. So let u be sin squared x, or it is sin x the whole squared. Further it is not so easy again, so we call z as sin x. Like that, u becomes z squared. So we'll take their derivatives. Z is in terms of x, so dz by dx is cos x, and u is in terms of z, so du by dz is going to be 2z. Like that, we are able to get du by dx because we are always eyeing on that du by dx. So that by formula is going to be du by dz times dz by dx. So like that, it is 2z times cos x, which is what? Yeah, either that you get it in terms of x here itself or later, but I think here it's easier. Z for us is sin x. 2 sin x cos x, or you can call it as sin 2x. So that's du by dx totally done. Also, we call v as cos squared y. Now this is going to be a little complicated because y, right? X is always easier because it's with respect to x. So, and here also we make that substitution w as cos y. So if w is cos y, then automatically v is w squared. So we will have dy by dw, it is minus sin y, and dv by dw is going to be 2w, but our intention is to get dv by dx. For that we are using a clever and intelligent rule of chain rule, use of chain rule. How? dv is with respect to w, so dv with dw, and dw is with respect to dy, but we want it with respect to x, so dy with respect to dx. That's all, chain rule. Now we'll put all these ingredients together. So we have this dv by dx now. What is dv by dx? Therefore, dv by dx is becoming dv by dw, that is 2w, and then minus sin y, and then dy by dx. Okay, w, if it's possible for us to revert back, yes, it's cos y. So it's minus 2 sin y cos y dy by dx, or rather it is minus sin 2y dy by dx. Now given is u plus v equal to 1, because we are always intending on the derivative with respect to x. We are taking the derivative with respect to x on both sides. So this is becoming du by dx, this is becoming dv by dx, and this derivative is 0 because the derivative of this thing with respect to a constant is always 0. Now du by dx we have it, it is sin 2x. dv by dx we have it, it is minus sin 2y dy by dx. This side it's 0. So let's have this term transported. Sin 2x becomes sin 2y dy by dx. Let dy by dx stay there and sin go on the other side. It's multiplication, so it goes on the other side, becomes division. Sin 2x by sin 2y, that is dy by dx, right? So that's about that one. So 9th problem, since I have lost it, I will take it once again. Y is what? Sin inverse of, y is sin inverse of 2x by 1 plus x squared. Now in all these kind of implicit function problems where we have this inverse trigonometric functions coming, this works excellent if you do a proper substitution. Okay, substitute x as some other function so that your function becomes more simpler and derivative becomes easier to be found out. It becomes easier to find the derivative. So That's our strategy, right? In this case, we have this familiar 2x by 1 plus x squared. We know that 2 tan theta by 1 plus tan squared theta is sine 2 theta. That's known to us. So because that is known to us, we make a very clever substitution, and what we do is let x be tan theta. Okay, so similarly you should know that theta is tan inverse of x also. Both ways you should know it. So what becomes y? Therefore y now becomes sine inverse of 2 tan theta. We are reverting back, okay? We are reverting to tan now. 1 plus tan squared theta. What is the idea behind this is, since we know that this is sine 2 theta, we are writing it as sine 2 theta. But what is the advantage? Sine inverse and sine, they are inverse functions. So they will reduce to identity function and you get a much simpler function. So this will become an identity function, and as a result you get only 2 theta, right? So y is 2 theta now, or in other words, theta for us is tan inverse of x. Now things are much more simpler. You can find the derivative. Taking derivatives on both sides, dy by dx is d by dx of 2 tan inverse x. We all know that 2 can go out, so it is 2 times derivative of tan inverse x. Tan inverse x we know, derivative is 1 by 1 plus x squared. So it is 1 by 1 plus x squared, or 2 by 1 plus x squared. That's all. So an intelligent substitution can spare you efforts. That's about it. Now way down, all problems are going to be like this. Proper substitution, get the answer. This also, those 3 will prompt you that it is tan 3 theta that is coming into the picture. So we have to use a clever substitution. So let say x be tan theta. So automatically theta is tan inverse of x. So what happens to y? Y becomes tan inverse of 3 tan theta minus tan cube theta by 1 minus 3 tan squared theta, which is a formula for tan 3 theta. So this is going to be tan inverse of tan 3 theta. Domain is applied to us and this fits into the domain. Okay, so that is why this, see, only when your variable is in the domain can tan inverse and tan behave as inverse functions. Otherwise it does create problems, right? Because it is comfortably in the domain, we need not check it. It is, I mean, we need not show it. We have to check it, but we need not show it. So this becomes an identity function. As a result, y becomes 3 theta or 3 theta. So theta we know is tan inverse x. We are taking derivatives on both sides. Dy by dx is becoming 3 times derivative of tan inverse x, which means it is 3 into 1 by 1 plus x squared, or rather it is 3 by 1 plus x squared. That is a derivative in this case. That's all about this part. With more problems, we are coming in the next part. Thank you.